Welcome to another video from eddycurrent.com. Today I'm filming on location from the NDT library, I like to call it. We're going to be going over some of the books I got in here and the manuals. And I'm just going to talk about some of the things I've learned over the years being in the power generation industry and sort of where I started my non-destructive testing journey, I guess you'd call it. And I had never even heard of non-destructive testing until I was about 18. And there was a school close by me that had a program. So I went there. That was Hutchinson Technical College. That's the wrong one. That's the wrong one. It used to be called Hutchinson Technical College or Technical Institute of Hutchinson. They had a 2-year NDT program, got a diploma. Got a job working for Babcock and Wilcox. So travel around doing tube testing. I started off as a level 1, and I think this was the manual. There's your 180, 60, 40, and 420s. That's about 1.5 inches thick. A lot of impedance graphs in there, and they talk a lot about how to inspect tubing. You're not going to go to a tubing company and learn how to do surface testing, usually. The closest thing you'll get to it is array probe testing, because that's kind of like surface testing, except inside of a tube, right? And then I was a level 1 for a year or two, and then I took the level 2 course. That was this manual. And then, let's see. Then I was going for analysis training, and at the time, they had a new analysis program coming out called the EPRI QDA, Qualified Data Analyst. Now, this company did steam generator tubing inspections, and when you're working in the nuclear world, you know, the training is pretty intense and robust and comprehensive because they want you to really know what you're doing and use multi-frequency testing to be able to separate the numerous variables that appear in the output of every eddy current test. So that's the EPRI QDA book. What do I have for scale in here? Roll of duct tape. There's a roll of duct tape. So that's about, what, 4 inches thick? Passes the weight test. It's at least 10 pounds. So I took that, and then here's EPRI. That's a steam generator tubing course. Yeah, a lot of stuff in there. That was actually the predecessor to the QDA book. And then, of course, they wrote a report on the multi-frequency eddy current system for inspection of steam generator tubing. And they said, so what's this, 78, 79? What's the date? 1980. So this is back when the Ms. 12 was hot on the market from Z-Tech. And this report basically says, hey, there's testers commercially available now, and you can collect a massive amount of information from tubes, but you have to analyze the data using that book and that book. And it's hard. It's really hard. That's why we got to do a lot of training. So then after that, I got my 2A cert, or my QDA cert, in about 96, I guess, 95, something like that. 96 is when the plus point came out. I do remember that. And then I kind of had a goal to become a level 3, right? So then I got the level 3 study guide from my old employer. That one's even thicker than the QDA book. That's about a 12-pounder, at least. So there's a lot of stuff in there. And does that include everything you need to know to become a level 3? Well, that depends. Do you want to be a pencil pusher, or do you want to be a guru and really know what you're doing technically? But there's a lot of administrative type stuff to learn in here, and there's a lot of technical stuff, and there's a lot of regulatory stuff. So it's a very, very broad range of sources of material that could be covered on a level 3 test, not only for eddy current, but for basic non-destructive testing techniques. There's 5 big ones. There's probably 100 or more of lesser known ones to NDT folks like us, but there are a bunch of them. There was over 80 of them back in about 1970, and that was per NDT legend Chuck Hellier. I spoke to him on the phone yesterday. So got my level 3 in 1996, I think it was, something like that. I think I have my, where's my thing here? Hold on a second. When's this one from? That's from 16. that's from 2016. That would have been the first, second, third. That's probably the third time I took it in 2016. Yes, I got my company level 3 in 95 or 6. Analysis search like a 92. AS&T in AS&T in 1996. So wow, it's almost 30 years ago. Time flies when you're having fun. So then I did a lot of analysis of tubing, eddy current steam generator tubing data analysis. At one time, probably about 10 years ago, I counted up how many refueling outages I was part of the team, and it was about 150 back then. And then since then I came to work for utility, so there's not quite as many, but there's still, I probably could add another 50 or so to that. And that's a lot of miles of tubing. You might look at a few hundred miles of tubing, on one job, maybe more, maybe less, but it adds up. You got to look at every inch. That's why you got to be highly trained and use software that's powerful enough to effectively evaluate that data. Then I did a bunch of work in Canada. That's where these books are from. I always say the best eddy current people are from Canada, but I got to throw a shout out for the UK because there's a lot of guys in Britain that are very, very knowledgeable about eddy current testing. But I was up in Canada working one time. We had a snowstorm, and they gave us we had like a week off, and they said you can either go home, and we're not going to pay you, or you can stay here and you can stay in the hotel and watch the snowfall and collect per diem. So a lot of people stayed. A lot of people went home. I stayed, and I found out that I could contract a guy to go to the Hamilton, Ontario vocational school where they had a program, and he would basically show me some equipment and the way they calibrate, eddy current data in Canada and some of the types of things that are covered for the practical exams that they give from the CGSB, a lot of that stuff. And I'm glad I did it because I learned a lot just about old testers and different types of tubing, because I was just a non-ferrous Inconel 600 thermally treated guy. So that's one type of tube, no fins, all prime surface. Tubing's usually pretty clean. But then when you got to go take a practical where you're doing a bunch of different types of tubing, you got to use different skills, and you got to know a lot of different things about test frequencies and types of flaws that affect different types of materials. Then that's not only tubing, but we had to do some aircraft wheels and some wings and different pieces and parts using different testers and cables and probes and operating modes. So how is the AS&T practical for the Eddy Current Level 3 versus the CGSB? Well, there's a big difference. The main big difference is AS&T doesn't have a practical yet for eddy current. I believe they have an eddy current. They have practicals for other methods, but I guess nobody's been around to build up the practical for the eddy current. So maybe that'll be a future project I'll get involved with. But the eddy current guys in Canada are really smart. So when I took that course, I did it because I wanted to take the CGSB Eddy Current Level 3, and at the time, I don't think there was that many in Canada, maybe 2, but that was the hardest test that I ever took with regards to eddy current testing. And if you know from your studies, you probably read about Leon Foucault. He was the guy from France he was studying eddy current, same time Faraday. And, in Canada and France, they don't say eddy current, they say courants de Foucault, or Foucault's currents. So yeah, that was a tough test. I stopped renewing it though because it was like $500 a year or something. Now it's even probably $1,000, but I don't do a lot of work in Canada, so I don't need it. But let's start going over some of this library. When I wanted to, sort of straighten up this library, because I'm going to give a Eddy Current Level 3 refresher course in about a month or so. And I always like to sort of go through my library and I thumb through, just kind of random books. And I've been through most of these books from cover to cover over the years. Not those ASM ones. Not those. Not all those corrosion ones. Not all those ASTM ones. Those are basically reference books that you use to look things up. But these books, all the Eddy Current ones especially, I've been through cover to cover, some of them multiple times. And let's see, as I go through these books from time to time, I might want to pull one out and just sort of talk about it a little bit. But you might be asking, gee, Ed, why would anybody need this many Eddy Current books and non-destructive testing books? Well, you don't need them, probably, for your particular job or maybe your career path. And a lot of times you just need to know the basics, right? But being in this business for a long, long time, I used to come across a lot of people that seemed to know it all. But then when I would ask them, well, where did you learn that? That's where things kind of got sketchy, right? And there are a lot of experts out there. And then there's a lot of people that think they're experts because they don't know all of the things that they don't know. And every industry has people like that. There's something called the Dunning-Kruger effect, where if you don't know what you don't know, you might think you know it all. Anyway, when I came out of school, I thought I knew it all, but I was quickly humbled when I got into the field, and that's when I started to take on the white glove mentality, or the white belt mentality, they call it. That's a karate term. And when you have a white belt, that's when you're humble and you go in there and you keep your mouth shut and you just listen to the sensei and you learn about honor and respect and discipline, all that kind of stuff. But you have to be open to new ideas, and you have to be very much a student to the sensei so you can master your craft. And basically, there's a term that I hear a lot in the nuclear industry, and I like to use it. It's like I know because I looked. So I can apply that to these books. When certain topics come up and I give my opinion or my stance on something, I can say, I know that because I looked, and here's the book, and here's the page, and here's the article, and here's why, that kind of thing. So I know because I looked, and that's a pretty powerful tool to use, especially when you have to back up, something you wrote in a report, or your position on an indication that's going to result in a costly repair. You got to have all your ducks in a row. And you always want to do all the tests that you can at your disposal, because once you leave the site and you pack up all your equipment, and people start asking questions, you can't go back and retest the tube. You gotta go with what you have. So always collect as much information as you could possibly need, especially for controversial indications. Now, some of you may have heard of AS&T Blue Books. Those are old training manuals. They got some RT, MTPT, UTVT. I probably got about 20 or 30 more of those, but I ran out of bookshelf space. These are only 2 bookshelves. So I started categorizing these. The Holy Grail of NDT books is that one up there in that little cardboard makeshift case. That's the 1959 edition of the AS&T NDT Handbook, edited by Robert McMaster, probably the biggest fan of non-destructive testing. In second place, I'm going to put Chuck Hellier. But Robert McMaster, I don't know if he was ever an NDT technician, but he was definitely a fan of all things quality related and non-destructive testing. So he was so interested in it and passionate about it, that he was president of AS&T, and he was the technical editor of a bunch of different manuals, and he loved researching the history of electromagnetic testing. And over the years, he gave many papers on the history of eddy current, starting back with David Hughes in 1826 or whatever it was, all the way through the scientist years, the Faradays, Maxwell's, and Joseph Henry making the electromagnets. And Joseph Henry made the electromagnet like 100 times stronger by just wrapping silk around the wires using the electromagnet. So I don't know how he figured, let's wrap some silk around it. But when he did, it made the magnet way, way stronger. And then, the history went covered. They had that terrible railroad crash back in like the early 1900s because of defective wheel or rails or something like that. So that's when people said, hey, we need to figure out a way to test these carbon steel materials for cracks so we can prevent all this unnecessary, catastrophic events. So eddy current testing really started to get, and electromagnetic testing, because they did a lot of carbon steel stuff in the beginning, started to get a lot of traction in the early 1900s. And then, of course, the World War II thing happened, and Dr. Forrester was very busy in his lab over in Germany. So he came up with a bunch of testers, pre, during, and post World War II, because there was a need to do non-destructive testing on tanks and ships and airplanes and all that kind of stuff. And after the war, he was generous enough to share, I don't know if it was everything he knew, but an awful lot that he knew he shared with a government employee from the United States named Richard Hochschild. And he went over to Forrester's lab and spent 6 months over there and basically shadowed him, and came back and did a brain dump with the Atomic Energy Commission, who funded his trip. And then he disseminated all of that information he learned to labs like Battelle and Oak Ridge. And they basically hit the ground running with this new knowledge that they had to start working on testers that could be used in the nuclear program in the United States. And then Hugo Lubbe, who worked for Hanford, he took what he learned from Hochschild, who learned from Forrester, and he started working on multi-frequency testing. So even though Forrester had the first impedance plane in like 1942, Libby never got one working until probably 15, 20 years later, but he was really focused on the multi-frequency testing, which basically rolled out in the early 80s, and today it's the staple, especially for tubing. You're always running at least 4 frequencies, sometimes more. If you're doing surface testing, you're usually not running multi-frequency, unless maybe you count 2 frequencies multi. I guess 2 is multi. Dual frequency, they call it. That's why you call them 500D and 2000D and 600D. Those are dual frequency units. I asked Riley Looper one time, he's like as old as a dinosaur, and I said, what'd you do back in the day if you saw an indication on 400 kilohertz and you're using the MIS 12 and you wanted to know what it looked like on 200 kilohertz? He goes, well, you go back and you retest the tube on 200 kilohertz. So just imagine how much time, effort, and unnecessary radiological dose that took. So multi-frequency saves you time, money, and dose. All right. So those two versions of the Non-Destructive Testing Handbook, Volume 1 and Volume 2. Volume 2 holds the secrets that most Eddy Current people wonder where the answers come from. It's Volume 2 of the 1959 Handbook. There's about 5 chapters in there that are authored almost completely by Dr. Forrester. All of the complex impedance plane diagrams that have puzzled Eddy Current practitioners for years are in that book. And why do I have, 8 copies of Volume 1 and Volume 2 up there? Well, they're rare, and I teach Eddy Current classes quite a bit. And if I ever come across somebody that's like really passionate and really wants to dig into it, then I'll maybe give them a copy of this set. And they usually appreciate that, especially if they look at it. So that's probably the most comprehensive book ever written on non-destructive testing. And, as future editions of this book get rolled out, there's a lot of new information. So to make room for the new, you got to get rid of some of the old. And a lot of the really foundational learnings and material on non-destructive testing that have been chronicled in these books isn't really discussed in a lot of the newer books. They're talking about computer modeling and, AI, all that kind of stuff. Now, so that was first edition. Those are all like 1959 or maybe a couple years later if they've revised something in there. And then, so that's, I guess, the original issue. And then you've got Rev 2. That's second edition. That's these brown ones from McMaster. Right? And then you got the third edition. For years, I didn't know that this was the later version of that. But there's a wealth of knowledge locked up in these 2 books. And, one time when I was studying for my level 3, I'm like, I'm just going to put this book in the bathroom. I'm going to study it 10 minutes at a time, right? And you may laugh, but that's a pretty effective study technique when you have a short attention span like me. I was going to read it from cover to cover, but it's not really the kind of book that you read from cover to cover. Nobody will have the patience for that. But it's an excellent reference book. If you want to learn about how to do eddy current on ball bearings, it's in there. If you want to read about why increasing metal coating on a conductive base always rotates clockwise, it's in there. Every topic that you can think of, most of them are probably in there. Then it was revised, Now this is going through the 4th edition, which will probably be out in the next year or so. Then we got, so these usually about the top shelf and a half are AS&T materials. This is the ET instructor package, yeah, I guess you call it. And it's basically the instructor notes when you teach an Eddy Current Level 3 course, or actually it's electromagnetic testing, because eddy current isn't enough for that test. You got to know all electromagnetic testing, all the basic ones anyways. Remote field testing, eddy current testing, and alternating current field measurement testing, which is done a lot of offshore and amusement parks. Then, so this is video sort of a good primer of what sort of stuff you can study if you're preparing for the Eddy Current Level 3 or the ET Level 3 exam. This is a classic, Fundamentals of Eddy Current Testing by Donald Hagemeyer. Donald was an NDT engineer. He worked for like Douglas Aircraft, McDonnell Douglas, probably did a stint with Boeing too, I'm not sure. But he, over the years, wrote, 15, 20 different articles on aircraft NDT. And that's a stack of Material Eval magazines from AS&T right there. He's got tons of articles in there. And, a lot of stuff doesn't change, when it comes to certain types of tests. So if you want to learn the basics about, fastener hole inspection using a rotating scanner, or doing multi-layer aluminum panels connected by rivets looking for second layer corrosion, a lot of it's locked up in those magazine editions. Not so much in this red book, because there's a lot of impedance graphs in there and vector diagrams, and there's a lot of electrical stuff in there. And he uses a lot of impedance plane diagrams to explain different effects like liftoff, thinning curves, thickness curves, permeability, realms of the impedance plane, non-ferrous down at the bottom impedance plane, ferrous on the top of the impedance plane domain. Let's see. So those are two of the same book. These are some interesting ones up here. Nondestructive Testing Overview. So that talks about NT in general, and this is special non-destructive testing methods. So they talk about a lot of the lesser known ones in there. I don't know if Barkhausen noise is mainstream yet or not, but that's when you can take listening apparatus and you can actually hear magnetic domain shifting under stress. They actually make testers for that some people in the airline industry I know use it, because they call me up and ask me how it worked. And then we got the book you see here. That's for Paul Mix. A lot of you old timers are going to say, hey, that's a great book. Well, it is. That's why it's in the library. Now, a lot of these books that I have are NDT, but a lot of them are Eddy Current specific. So let's start over here. This is a AS&T Level 3 study guide for basic. So what are you going to talk about there? Well, to pass the basic, you have to have level 2 knowledge in all of the main NDT methods, UTMT, PT, VT, whatever, and then you got to have the level 3 knowledge for the method that you're testing in. So in your case, if you're going for the ET exam, you need to know a bit more about eddy current, ACFM, and RFT. Then you got the level 3 study guide, so that goes into things a little bit more depth. This is the book that you actually use if you go through the AS&T ET course. Then you got the question and answer books, where they give a bunch of practice question and answers. And, on these exams, the questions can come out of books that are 50, 60 years old, and to try to find the material that support the question and answers for some of these old theory type questions can be a bit tricky. Hence why I have such a big library, because I was always in a quest to sort of back up some of these question and answers. I wanted to know the why. I was always asking why. Okay, another book for level 3 is the Material and Processes for NDT Technology. Very important. So I always like to, during my courses, just read the table of contents. Where is it? Did I skip right over it? All right. Let's take a look at these chapters. Relation of NDT to manufacturing. Introduction to manufacturing. Properties of materials. The nature of materials and solid state changes in metals. Ferrous metals, non-ferrous metals, and plastics. The nature of manufacturing. Casting process, welding process, plastic flow and deformation, millwork, forging, powder metallurgy, sheet metal, press working, machining fundamentals, miscellaneous processes, finishing of materials, case hardening, and inspection procedures. So when you're level 3, it's not just about turning on a tester or spraying a can of penetrant and looking for the crack. To be really good at it and to give your client the money's worth, you need to know a bit about materials. You know, different materials are susceptible to different types of discontinuities. You know, you might have a cold lap in forging. I guess that's where you get them. I don't inspect forgings. But, you know, certain types of tubing will have corrosion. Other ones, not so much corrosion, but are more susceptible to mechanical wear. The welding process, usually if you go through a non-destructive testing program, a formal one, you'll get some sort of welding training and you'll have to go do a bunch of welds. You know, doing, TIG welding and arc welding and flux welding and submerged arc welding, because you have to know, you got to learn about how hard it is to do some of these welds high quality, so you understand what types of flaws can be introduced to metals. Because when you're doing NDT methods, you're going to see a lot of artifacts that they're probably discontinuities, but they're probably discontinuities that, you know, don't change much over time. So do you really need to repair that, or you just need to monitor it? So it helps to have all that kind of knowledge. Now, these books here, these were a lot of old questions from like cathode ray tubes come from, and horizontal and vertical deflection plates. These books are written in the 50s and 60s, and a lot of eddy current folks cut their teeth on these old Convair books. Those are the ones with the program and instruction where you read page 1 and ask you a question. If yes, go to page 2, and if no, go to page 3. So they kind of go through that, but there's a lot of electrical diagrams in here and a lot of just really, really basic NDT and eddy current testing, type of subject matter. So they're good, but they were good for the time because that's really all that was out there. Now there are some much, much better books that have a lot more modern day information. So these are, widely commercially available books. You can still even get these. I think George Farragut's company, I don't even know what the company's called, but they still have versions of this particular book that you can get. And there was later one in here that got edited by Jim Cox, former training manager for Z-Tech. So he added some stuff in there. He even had a part in there about where the phase 0 to 180 kind of flip-flopped in about 1980. Instead of 0 being on the right and phase angles increasing counterclockwise on the impedance graph, it flipped like in 1980. And he sort of alluded to why that was in here without giving an exact answer. So I think he called it an artifact of instrument development. So anyways, he left a little bit of mystery in there. Then, I'm always on Amazon looking for new books, and there's, Practical Eddy Current Testing. I think that guy's from India. And then we've got the Faraday, the Maxwell, talking about some of the fundamental electromagnetic stuff. There's quite a few books I have that came out of Great Britain. Really good. A lot of them are from the 50s. And I picked up some books from NASA and the Air Force. Impact of non-destructive testing. I've got some on the financial justification to do non-destructive testing. This one's an oldie. This one guy, I think, Ju Jianbu Wu, I think he comes out of Australia. Not sure. Let's see. This one's really good. I'm not sure where he's from, but Peter Scholl. This is NDT, but he's got some good eddy current stuff in there too. Then there's some books that I get and I buy them because they got electromagnetics or eddy current in the title, and I get them and they're like rocket science raised to the exponent. they're they're far more than what I can make use of. So I talked about the Canadians being good at eddy current. All you got to do is look through some of those material evals, go back and look through some of the RD Tech ads, and then of course the Edify ads. I mean, they got a lot of really bright guys making some great testers. But the Canadian General Standards Board or Bureau, I forget what the acronym's for, but they're like the ASNT of the north of Canada. And this was my training book that I got from the Hamilton NDT school. At one point, I got my Germany analysis cert. So that's the EN 73 sector cert. So that's a training book for that. Now, these books came out of the AECL, Atomic Energy Canada Limited. And these were Val Checo and George Van Drunen and F.L. Sharp. Those guys knew a lot about eddy current. I guess they were Canadian. But they've got a level 1, level 2, and then they've got an applications book. So they basically go through all of the testing that they did to support the math that they're talking about in these books. And if you're a fan of math, you're going to love these orange books. And then these are just reprints of those orange books. Now, these two books from Eclipse Scientific, these were written by another Canadian, partially anyway, Michael Wright. There's part in this book, he said he was inspired by eddy current guru Steve Butcher from Canada. And Steve told him how cool eddy current was, and he started studying it, and he went crazy with it. So he wrote a book on eddy current testing technology, which is probably the most up-to-date book out there, using modern test instruments and, using a language that people can understand. If you're reading some of these books back from the 50s, they were written by engineers for engineers pretty much. But these use a language that most people can understand. And then they came out with one on array technology. And, if you're new to array probe testing, there's a lot of technology involved with it, with lots of frequencies, lots of channels. You got transmit, receive. You got the position of coils. You've got which coil pairs see acts and circs, and the behavior of arrays and the advantages, limitations. A lot of that stuff's covered in this eddy current array book. So that's probably the only good book out there that I know of on array probe testing. They're probably a couple $100 each, but well worth it. This one, Permanent Magnet Handbook. Eddy current testing is an electromagnetic test method. Wouldn't it be good to know a lot about magnets? Well, this book talks a lot about magnets. And then I came across this book. I think this maybe came out of, I learned a lot about books and found out about books about reading the bibliography of other books. And I know this was recommended in maybe one of the Canadian books, or it could have even been the Hugo Libby book, but Hugo Libby maybe been before the time of this author. But I'm like, Introduction to Electric Circuits. Well, I always tell people, I said, you know what, I'm kind of an eddy current expert, but I don't know shit about electricity or electronics, and it's kind of true, But I was surprised when I read this book on Introduction to Electric Circuits, how much stuff I already knew because I studied a lot about ET. When it gets into coil properties and magnetic properties, and inductive reactance and resistance and conductivity and resistivity and inductors and coils and yokes and how magnetic fields can store energy and eddy currents give off heat, when they penetrate through material. I'm like, whoa, I guess I do know a little bit about electric circuits. Then you got these books, The Inspection of Metals. So now we start to get into different books that talk about, materials from the earth, when they take materials out of the ground and then they bring it into the steel mill and then they refine it and they purify it and they pour it into ingots and then they form it and then they finish it and then they inspect it. That's, some of them are about iron, some about ferrous materials. This one's iron and steel. This non-destructive testing book, I remember I like it because I got some tabs in it, and I know this is an old one. This one's written by J.F. Hinsley. This book came out of London in 1959. So what could I possibly have highlighted in here? Maybe I thought this was a cool graphic. I don't know. Let's see, what's another one? Oh, this is a good one. In a lot of the books you'll read about, automation, eddy current and automation, like factories. They got conveyor belts and alarm gates and sorting boxes. And you hear about this stuff, but you never actually see a picture of it or a graphic. But some of these books, they went and took the time to actually show how this stuff worked. So when you read about paint guns and sorting gates and cutting tools, sometimes you have to dig through these old books to actually lay your eyes on what that stuff actually looked like. So that's probably why I liked that book. And I got some little books here. This one's from the Atomic Energy Commission. It's just an overview of non-destructive testing. I know one of the first articles in here, they talk about a lady that had some guests over and she wanted to use her fine china, but one of the plates had a fine crack in it. And she was examining it. By looking at it, she was kind of running her fingernail over the crack to see how it felt. And then she was thinking about what a lot of engineers have to think about. Do I run the risk of serving my spaghetti with the sauce, the gravy, as the Italians call it? I got to run the risk of this plate breaking and having a big mess to clean up. Or, I can risk it and hopefully nothing will happen. And then people can see how cool we are because we got this great fine china. So risk assessment is a part of non-destructive testing, right? And there's books written on risk assessment. And there's always engineers doing risk assessment when they put components back into service. And what type of flaws can you live with, that kind of thing. So that's a good book. They talk about feeling the tomatoes when you go to the grocery store. That's a type of non-destructive testing. How about when you put, the soda machine where you put your coins in? You know how many people tried to make slugs and put in there, but they didn't work? That's because they have non-destructive testing circuits that check the shape of the coin and the weight of the coin, and they electrically measure it, probably with some sort of eddy current testing. And then they reject. And probably today, you've got an alarm going straight to the police station. So don't use counterfeit coins. You'll get caught. Okay. This one's edited by George Free, Eddy Current Characterization, Material, and Structures. Any of you old timers, you know the name George Free. I hear it from Chuck Hellier all the time, and that guy really knew his stuff. Paul Mix, Introduction AT, great book. I know there's one or two of you out there that are going to say, oh, but do you have the Jack Blitz book? I do. It's right here. Troy Wooler from ZTech says you should get the Hugo Libby book. I'm like, I have both editions of it. It's right here. This is a tough read because Hugo Libby was really big into the math, and he loved to write about it. And I've gone through every chapter in here page by page numerous times. One of the projects that I'm working on now is Libby for the Rest of Us, and it's basically decoding this whole book of like, chapter 1, hey, we should come up with a multi-frequency tester. Chapter 2, some of the challenges of doing multi-frequency testing. Chapter 3, we're starting to figure out what kind of circuits we need to give phase spread to our signals. So when you sort of decode this into like 10 or 12 different chapter chunks using modern language and then tell how that applies to what we do today, most of his foundational work is actually used in application today. All right. I heard a name dropped George Free. What about, I got another great one here if I can find where I put it. It's in here somewhere. It's Frank Iddings, past president of AS&T. Is it this one here? I got one of these. It's written by George Quinn. And George Quinn was another one of Chuck Hellier's go-to guys for eddy current testing because he was really good at it. And he actually put some things into Chuck's book that when I read them in Chuck Hellier's book, I'm like, wow, I never heard that before. And it turned out to be one of those things I didn't know about eddy current. Now, why do I have Chuck Hellier's 2 books up there? That's because behind Robert McMaster. You know, Chuck Hellier and McMaster were buddies. He was recently telling me about how he was having dinner over at Robert McMaster's house, and he took him in the basement, and his basement was nothing but books. And on his desk, it was like 3 feet of magazines and books that he was editing and reports. And, you know, so, yeah, some of Robert McMaster's enthusiasm for non-destructive testing, Chuck Hellier caught the bug, right? So he's got multiple editions of this, and they're NDT in general. But then he's got probably the most comprehensive version is this one. And, you know, he sent me a copy. That's what he said. To Ed Korkowski, with my best wishes for continued success at NDT. Thanks for your effort with the new online courses, Chuck Hellier. He forgot to write NDT icon there, but it was 5 years ago. It's a great book. I think chapter 8's Eddy Current. So we'll put that back up there. Now, what else do we got in here? John Allen, Eddy Current Practice. That's a nice little, you could read that in an hour or so. Some of you old timers are going to say, what about William Lord? This book is excellent. Back around 1980 time frame. William Lord, I think he worked at the University of Colorado, but he was deep into electromagnetics. And a lot of the early eddy current modeling, which is some of the foundational work for modern day automated analysis, you know, he was a founder of a lot of that type of information. So William Lord is definitely a pioneer. Hopefully, you should get some more credit out there. Let's see what else we got in here. Now, you know, I got the slide rule. Talk about the slide rule a lot. And I also have I got just about every eddy current math book that you can get your hands on, formula books and stuff. Some are better than others. But you know, when I was recreating the slide rule, I got some of the older ones. I think this one from Nortec was the OG slide rule. Now you can tell when somebody uses a slide rule, all right? And the way you can tell on this one is that if you look along the bottom there, he scribed in with a pen F90. That's 1.1 standard depth penetration at the complete wall thickness. Then he put in 162 degrees. He put a little scribe, and he wrote in the ZTEC ZQA 4.1 curve. That's the frequency required by ASME code to give you proper resolution between near and far surface shallow flaws. So that's the frequency with high phase spread, 1.5 standard depth penetration. And then we got the, this one's so old, it doesn't even have millimeters on the back of the slider. You know, it's only got, let's see, let me pull it out here. It's got mils on the front, nothing on the back. Then later, this one came along, and this one, mils on the front, millimeters on the back. And then, of course, you got the current version that just has a few more figures on the back that sort of help you understand some of the theory and the formulations that go into these log charts that can help you do a variety of things with eddy current test frequency selection. All right, study manuals. Oh, let's get into some Chuck Hellier level 3 courses. So when I was prepping for my not my first one, because I self-studied for my first level 3 exams, but after I started working for the power company, they would send us to these refresher courses. So I went to 1, 2, 3, 4. I think I went to a Hellier course 4 times. And, you know, you always learn a little something new, just like when you read a book. You know, you go through it the second time, and it's like, man, why didn't I read that before? Well, because you were daydreaming. But definitely good courses back in the Chuck Hellier day. So I've been through those a number of times, and then let's move over. Up on the top there, there's a bunch of welding magazines. You got to know a bit about welding when it comes to being an NDT professional. Now, what I like about these material eval magazines, if you don't have a subscription to that, I suggest that you do. And it's not really a direct subscription to it, but if you get a membership in AS&T, which I don't know, it's maybe $100 a year, you get free digital access to the current magazines. Also, you get access to the archive going back a number of years. But at one point, I went through these and I sort of categorized them. You know, every year they'll put out an issue on research symposiums. These are all different years. Then they'll have the ready reference books. These are place where you go to reference different things: equipment, services, educational institutions. Then we've got some of them are just on computed tomography, some are on digital transformation. There's some later editions, in the last couple of years of Chat GPT and NDT, AI, NDT education and training, NDT of metals. Then, of course, you always have industry-specific issues that roll out, like NDT in the automotive industry, the food industry, art and culture. Like the Shroud of Turin. You ever read about the Shroud of Turin? You know how much non-destructive testing has been done on that thing? And the more testing they do, the more they want to do, because nobody can debunk that thing. Like, that's a real piece of history there. What about the pyramids? They're doing a bunch of non-destructive testing underneath the ground of the pyramids of Giza and the Giza Plateau, because they think pre-Egyptians were using the pyramids as big power plants. So there's NDT on that topic. And then they break it down. They'll have issues based on method. Laser, radiography, eddy current, electromagnetic, acoustic emission. Then they get into other industries: railroads, infrastructure, emerging technologies, new stuff, aerospace, NDT. I remember back in the day, I used to pay for articles that I found interesting. It's like $20 per article. That's a bargain compared to Corrosion magazine, because those articles are like $50 a piece. And these books are basically a collection of papers from Corrosion magazine. So how many are in that book there? $60 times probably 50 papers. That's like $3,000 if you had to pay for all of it. But I got them all right here for that whole collection. Because when you're an NDT practitioner, you got to know a bit about welding and corrosion, NDT and material and processes. Then we get into ASM, ASTM, a lot of books on codes and standards. You can learn a lot about the capabilities of NDT by looking through some of those books, because there's basically a published standard for every type of NDT test. You want to do radiographs for ferromagnetic welds? There's a standard for how to do it. You want to test carbon steel tubing with remote field testing, multi-frequency? There's a standard test for that. You want to read about it? Go get some of these books. Then we have, what about this big blue book here, Steam? Did you ever think you could have a book that thick on steam? Steam is very complex. That stuff you see coming out of your coffee pot, or your teapot, that's not steam, that's water vapor. You can't even see steam, it's invisible. Let's see, then we got an EPRI book. This is an EPRI book that's all about the types of discontinuities you can find in steam generators. So that's a big, thick book, because there's a lot of stuff that goes on in those components. Then we've got, and we're getting down to the end, we've got welding books and standard books, and then we've got some introduction to nuclear engineering. We've got steam generators for nuclear power plants. We've got some books on aircraft NDT. Then getting down to the bottom and getting into some radiography and other Hellier non-destructive testing courses. And again, this is about 2/3 of the library. I was thinking about if there's actually a non-destructive testing record for the amount of books that one can have on NDT and eddy current private collection. If there's not a record, I might check into that application, because it's starting to be a pretty big collection. And please, if you know of any good NDT books or ET or eddy current books, if you could drop a comment in there, because I'd like to add them to the library. And I was going to also include some like pictures of equipment and probes and tubing and samples and cow blocks in this video, but it's already, approaching an hour in length. So I'll just save that for another video. But you can tell I got a lot of history here and a lot of research, and a lot of experience in both surface and tube testing, rotating coil, inside bobbin coil, surface probes, array testing, automated testing, automated analysis, automated acquisition, a lot of that type of experience. So when you do take a course from me, you're basically getting access to all of that stuff. And I've gone through all these old books, and I kind of have figured out what was important back 50 years ago, and then what sort of things that you can sort of abandon and still become a very effective technician and analyst these days. What do you really need to know? What do you need to know for test, and what do you need to know to be the best that you possibly could be as an NDT practitioner? So there you go. A little bit about went into my non-destructive testing level 3 journey over the years. And, I learned something new with every magazine I pick up or every book that I read, and even every test that I perform. You're always learning something new. Oh, what happens if I look at this on a different frequency? Or what happens if I modify my probe a little bit or use maybe a little bit better cable? Just all sorts of things. So it's a never-ending learning journey. You can ask Dave Russell, Canada. He's like the RFT king. He's still learning something every day. We had a phone call not too long ago, and I just saw him up in Minneapolis for a conference, and he's kind of like Forrester, curious, and he's generous. So he's always learning something new, and he's more than willing to share his knowledge because he likes to see people that are passionate about the business, and he's very happy to share his knowledge. So alrighty then, I hope you enjoyed the video. Have a nice day.